And hello again, and here we are back in my garage on quite a cold, dark night. It's certainly getting a bit colder now, and it's now midweek, and this is the first chance I've had to come and work on the bike all week. So not much done yet, but there are things happening at the moment. So at the moment I've just bought myself these two little things here, these little dog bones. I'm sure you can't see them, but these are from Hell, and they hold the dash pots for the clutch and the front brake in place. So I picked them up when I was at Stafford, the Stafford Classic Bike Show at the weekend, so I can use them to put the dash pots in place. I've also been busy because I have just finished fitting the brake lines and clutch line to the bike, and thankfully they fit in the bike okay. I got my measurements, angles correct, so it's on the bike now, look pretty good. I'll show you that in a minute, but in the meantime I've also had a delivery today of something I need to sort out, a big problem on the bike. And as I mentioned in the last video, that problem is that the chain alignment is way off between the front sprocket and the rear sprocket. So here I've got my straight bar again against the rear sprocket, and you can see I'm miles out here. I'm out by about 9mm, so what I want to do is find a sprocket which has the teeth about 9mm further out. Or of course, as I also mentioned last time, I could machine the hub on the rear wheel back by 9mm. But I don't want to do that because, well, it's just going to be a lot of work and it's fraught with possibilities of things going wrong. So for me it's a lot easier just to find a suitable sprocket at the back here. Let me just move this out of the way. There we go. Move that out of the way. So yeah, all I've got to do is find a different version of this sprocket. Now this one's from a ZZR 1100, and it's got a 5/8 offset built into it. What I need is an extra 9 or 10mm, which brings it out to about an inch. So you think, no problem, just go and buy one. But you just can't get them. I have looked everywhere. I've checked with Talon, they've got at least a 6 months lead time. I probably won't do it anyway. I've checked all the American sites, can't get them. So, you know, what do I do? What do I do? And so because I can't buy what I want, I guess I better make it instead. And that gave me an idea. So what I've done is, I have bought myself a flat sprocket, same as this one, but a flat one. And it turns out that the thickness of the teeth on this 530 sprocket is about 9mm, which is, guess what, the offset that I need. So if we could somehow join this flat one to the offset one, the outer teeth here will be in the correct position. So what I'm going to do is, I'm going to grind off all the teeth on this 5/8 sprocket, leave this one alone, except get them aligned and then weld them together. And the tricky bit there is to make sure they're aligned, because you don't want it wobbling around and being offset. So to do that, we'll have to go to Jeff's workshop, and hopefully he'll have a spline shaft long enough to take both of these, because the splines are both the same. Put them on that shaft and then get them welded together. That might sound a bit weird, and it certainly is a bit weird, but it's something that used to be done quite a lot in the drag racing world. When you can't go and buy what you want, you're going to make it. So it's not something that's kind of completely out there and it's never been done before. The only slight issue I've got is, you know, hopefully we've got a shaft long enough to go through both, because if we haven't, then you can't really guarantee it's going to be all aligned when we weld them together. The other thing we'll then do is, once we're welded together, we'll machine out the centre of this outer one, which is splined, because it doesn't need to be, the shaft won't go that long on the bike. But then we'll use that hole that's now been machined out to hold the Outrigger shaft, which will come out and go into the outer plate, which is, where's it gone? Down here somewhere. Which is going to go into this bearing here. And this is the outer plate of the Outrigger. So hopefully it'll also work together and we'll end up with quite a good usable solution. Okay, so next thing then is that I need to set up the timing on the Dyna S ignition on the engine before I try and start it up. And to that end I went to see Les of the day, because he was doing the exact same thing on a Kawasaki Z650 with the same setup as me, the same Dyna S ignition. So I sat there, went through the process. Yeah, I think I can follow that now. But he did mention that there's already a really good video, about half hour long video on YouTube, which covers the whole thing from installing the Dyna S ignition to timing it and so on. And I watched that, and it's really good. So there's no point me going through the whole process again, because I'll never match the clarity of what this video tells you about. And so I'll put the link to that video in the description below, so you can follow that if need be. Now let's turn the camera around and look at the brake lines that I've got fitted on the bike. And so for the front brake, I'm running 2 separate brake lines down to each caliper. And to do that, of course, I need a double length banjo bolt, which I've got here from Hell. Whereas on the clutch side, of course, we've just got one long line which goes all the way down to the engine where the slave cylinder is. In fact, that slave is on the outer plate of the Outrigger. Now, one thing I will point out is that from the factory you get heat shrink attached to the line here. You can see it, and this heat shrink hasn't yet been shrunken, if you like, because it should go around about here. And the reason for that is that when you get the lines, it's possible that this banjo is at the wrong angle. Perhaps you want it like that, and it's actually like that, because the factory don't know what you want. So they leave this shrink off, so you can get a pair of pliers on here, put a rod through the end of the banjo and spin it round, because it will spin. It's not easy, but it'll go. And you can do that to get them just right, and it doesn't affect the sealant or anything like that. It doesn't affect the sealing of the banjo. So away you go. Once you've done that, then you can come along, move that back, and then heat shrink it in place. And of course then you don't damage it if you need to change it at a later date. So yeah, that's actually useful to know. And finally for tonight, when I go and see Jeff in his workshop tomorrow to sort out this problem with my 2 sprockets, I'll also collect the various spacers and pillars that he's had to modify to make this outer plate of the Outrigger system fit perfectly on the bike, because the various spacers and pillars were made a little bit too long. Deliberately so, by the way, because we weren't quite sure the precise fitment when it's on the bike. So it's best to make them a little bit too long rather than a bit too short, because you can always take off a bit when needed. So I'll hopefully go and collect those tomorrow, and that'll mean I can finally get this thing fitted to the bike, you know, at least temporarily anyway, because obviously I can't fit it when I've still not sorted out the front sprocket. So that's something for tomorrow. So hopefully I'll take the camera then, and we'll catch up at Jeff's workshop in the morning. Right, so Jeff, here we are in your workshop. I've just brought this big parcel, which we'll cover in a minute. Yeah. That's not part of this particular project, so we'll ignore that for the time being. Put it on the floor, where no doubt I'll trip over it. And what I brought, Jeff, is this ZZR 1100 offset front sprocket by 5/8, and this flat summer sprocket. And the idea was we'll grind off the teeth of this one and then get them aligned and weld them together, and that gives me the offset I need to work with the 1170. But as usual, you've got a different idea, hopefully a better idea. So well, what we've got here is,
it would save a lot of
bother.
It's a mither.
Yes, it's actually quite heavy, isn't it? Because it's solid.
Yeah, but I mean, but don't forget.
Right, so it's made by Dunlop, I think, and this actually is a 630.
That's for the comp bike. Yeah, sorry, the spares bike.
Spares bike. So what this is a, what's it called again? A pilot hole.
A pilot bore sprocket, they call it.
A pilot bore sprocket. And as you can see, it's a sprocket, obviously, but it's made with this huge, great big offset built into it. And this bit here is solid steel. It's like really heavy. The reason being so that you can machine it down and make it fit however you like.
I think originally a lot of them's for power transmissions.
Yeah, power transmission. So we just gone on eBay and bought one of these, but for a 530.
530, and I've got one somewhere.
I know you have. I wanted a 17, couldn't find a 17, we could find an 18, so we'll go for the 18.
I think the one I've got might be a 16.
Yeah. So Jeff's idea, which he reckons is going to be a lot easier than trying to weld these two together, is to get one of these things, machine out the centre somewhat.
Well, then, set one of them up on a shaft.
Yes, I'm sorry. Yeah, we'll go back a little step. First of all, we'll get one of these. I think you said you've got an old one.
I've got an old one
with one teeth, but the splines in the centre are still good.
Yeah.
So we'll machine out. We'll machine out the centre. So it's just like a disc.
Bolt it to a shaft, and we'll put it between centres so that it's accurate.
So it's on that.
Yeah.
So it's a disc with a hole in the middle, which is splined. We'll then machine a hole in this thing when it arrives.
The bigger in diameter we can make it, the better.
And then we'll put this disc.
Press it in.
Press it in.
Well, we'll V it.
Yeah.
And then either you can take it to Jeff and get him to
weld it. Yeah.
Well, run a nice big weld round it.
Yeah. So we're still making a one-off sprocket. We're just doing it a different way.
Yeah. The only snag is, like you say, these aren't hardened.
No.
And over the years, depending on mileage,
which will not be very high.
But the thing is, if it don't cost a lot to make one, and it wears out in
I can't make another one.
20,000 miles.
Yeah. Well, I'll not be doing 20,000 miles on my bike. I'll be dead by then.
Well,
At least on that particular bike, anyway.
Well, the thing is, it's got an aluminium one on the back, so
Yes, yeah. Well, there is a change.
that in theory should outlast
Me and you.
the one that's that's twice the size. In theory, they should wear
Yes.
maybe about the same.
Now the other thing is,
We don't
which
know.
we mustn't forget, is that this will also need a method of attaching a shaft on the outside to go to the outrigger bearing. So that's something we have to take into account when we make the thing. So yeah, that's an idea I didn't actually consider, because I didn't know these things existed, to be honest. So yeah.
What we'll do, we'll bore it out, and if we machine a spigot with a shaft that'll then push in, that'll sit in the bearing, it'll help to support it.
That's
a
the
little
whole point.
bit,
I don't want to put an outrigger on it and it's just there for show.
No.
I want it to work. So.
Well, it'll look like it's working.
Well, hopefully it will work.
Yeah. Now the snag is, you see, if you bought it, because of that, I've had this trouble in the past.
Go on.
And if you bolt, if all that's done, by the time all that's bolted up, and we've machined that out, the odds of that running to a thou is highly unlikely. And if you get something that you tap in, or is a nice snug fit, and then it's only a fraction here, it can be like running. So
well,
the idea,
I know.
the idea is, if we bore that out, what we'll do is we'll hopefully, if we can, we'll put a very faint bevel on it, so it actually
allows it to flex.
To.
Well, if you go back in time about 20 years,
settle.
I'll go back in time 20 years, I had the exact same problem with the front drive on my 4-inch belt drive on my Harley, which had a similar outrigger support system. This is a £3,000 kit from Germany, and it kept on, the bolt that held it in place kept on.
It's trying to,
I mean, it's locked tight in place, it's really torqued down, it still kept undone, and once it came off at about 100 miles an hour, which ruined it almost. And then in fact, it might have been why I went to see you for the very first time, and I said, look, I've got this problem here.
You regret it.
Yeah, and it's like,
and you've regretted
anyway,
it.
you looked at it and said, yeah, I know what the problem is, we can sort it out. So I'm going, oh God, how much is it going to cost me? And I think your answer was, well, go and get the fish and chips for the supper, and I'll make a start on it now. And you did it within about an hour or two, machined it all up, put it on the bike, works fine. Yeah, and the problem was that we had a pulley, and it had an extension from the pulley, from the nut. It was a nut that holds the pulley in place. It had an extension on it that came out to a bearing, and the problem was that nut was not absolutely perfect. It might have been a thou out or something like that, because it came on the end of the crank.
Yeah.
And by the time it had come out about 6 inches,
it multiplies.
It multiplies it by, say, I don't know, 5 thou or something like that, and it was flexing slightly, and that was the thing that was making it come undone. Yeah, so
you can't even put a self-aligning bearing in, because you can only have a self-aligning bearing if each end's got one in. That takes out any. Yeah.
And your solution was, as I remember, was we took this shaft that had a nut on one end, cut it in half, or cut it in two, and then we kept the top hat bearing at the end, and you machined a plate that sat on the very edge of the pulley, so that it's separating the pulley support from the actual shaft of the crank. So yeah, it worked quite well.
So, like you say, what we'll do when we put something in there, instead of it being flat, it wants a very faint
radius on it.
Very radius, so actually it goes in and it's got that tiny bit of give.
Bit of leeway.
Yeah.
In fact, a bit of leeway.
Yeah. But if it's on the bearing there, it will help to give it support.
And by tiny we mean like a thou of a mil or something. Or whatever,
it might just want something like a 5 thou bevel.
Okay, good. So
just to take out that harshness of it.
Okay, so we've got one of these things arriving next week, so when it arrives we can do some work on that. And so now here we are, back home again, and I've got this outer plate of the outrigger in place at last. So these pillars are correct, the spacers are in place, and we're all ready to go. Except, of course, I can't fit it for the last time yet, because I'm waiting for the one-off sprocket to go on it, and also we need to make a shaft to go into this bearing here and support the sprocket. But I've still got 2 more things to do this week, and the first of those is to make a linkage piece to go from the gear change lever to this point here on the gear change shaft. And to do that, I've got this generic piece here which slides onto the gear change shaft like that. And I've measured the distance centre to centre of this hole here, which will take the link piece, the link arm here. That's 33mm. So on here we need to make a bracket which can be welded onto this thing, which will give me 33mm from the centre of this out to a hole which will then connect to the link arm. So I've got to make that. Can't do welding myself, so I'm just going to make the bracket and then take it to Jeff the welder, and he can weld it on at some point in the next few days. I can also now take this big, long, 1 metre long, 8mm bar, and I need to measure it so I can make the push rod to go behind here, because the push rod goes behind the slave all the way into the engine and obviously activates the clutch. So I've got to push that in there and measure the precise distance I need to get this thing working spot on. I won't do that today because I've run out of time, but that's another job for the next few days. And so now I've got to measure and cut this 8mm bar to make myself a new clutch push rod. So I've cut it down a little bit, and now we'll see how it goes in the engine. There it goes. Okay, now it looks like I've almost got it right, because I estimated it needs to be about level with the inside face of this outer plate, because here we have the over and slave. When it's fitted, this ball bearing here in the middle, which is where it touches this bar, is about level with the inside of the plate, as I say. So now let's just very gently fit that back on the plate. Oh, look at that, yeah. Look at that, it's just rocking a little bit. I'm probably about 2 or 3mm out, so I've actually done quite well there. Now, the problem is, hang on, let's take it off there. So it's 2 or 3mm out. What I've got to do now is reduce this down by about 2 or 3mm. It can be a little bit too short because the difference will be taken up by the hydraulic piston as you operate the clutch, but it can't be too long, because otherwise then you've got pressure on the clutch at all times, which is no good at all. So let me just pull this out, and we'll just file down. Here we go. We'll file down the end here and then round it off, and hopefully that's our new push rod made. And so with power going to the M unit, suddenly the whole bike comes alive. I've got the instrument pods all lit up, I've got power to the lights, indicators, and most importantly right now to the Dyna S ignition, because I've just been setting the static timing for the ignition. And I didn't film that because I'm doing it down here, and I've got about 2 feet of gap between the bike and the wall here, so I can't really film it. And besides, as I've already mentioned, there's a fantastic video which covers all this far better than I can already on YouTube. And as I already mentioned, the link to that video I'll put down in the description of the video below. So with that done then, I've now got to put some oil in the engine and find a way of setting up a fuel supply to the carbs, and then at last we can maybe try and start the bike for the first time. Now when it comes to fuel supply, I've just bought myself this temporary fuel supply bottle here. It cost about £20 I think from Amazon. It's got a pet cup on the bottom, so hopefully just hang it up and then run the line down to the carbs. Once that's all done and it's safely set up, I can, as I say, try and start the engine for the very first time. So now then, I'll put some oil in the engine, sort this out, and we'll come back and try and start the engine, as I say, for the very, very first time. A bit worrying, but hopefully things will go okay. Well, as you can see, things didn't go according to plan. Oil's everywhere, I was panicking. And the reason was, the engine doesn't have a sump plug in it, which I just assumed it would have, but it doesn't. No idea why, I'll have to go and buy one I guess, I don't have one. So all the oil just went straight in the engine and straight out again. And before I realised, I've used a litre or so of oil, very expensive oil at that. So I'm a bit not very happy about this, but you know, that's me being stupid and rushing things. I just assumed it would be there, but it's not. So yeah, I'm just showing you this because it just shows you that, you know, things do not go according to plan, and rushing things, you end up with a waste of oil and a lot of mess to clean up in a minute. So yeah, lesson learned I guess. Check you got a sump plug in the engine before you start putting oil in it. Anyway, I'll clean this up now and we'll try again later on when I've got a sump plug.